Hi everyone. Today we're going to study special products of these forms. Two forms will be of this type, and the third special product will be of this form. Let's begin with our first type. In here we're going to multiply binomial and trinomial of this form. In the book you will find the special product for this to be a binomial, which is x cubed plus y cubed. So let us examine our factors here. Look at the binomial x plus y. If we look at our product, it is x cubed plus y cubed. It seems like we are simply putting the cube on each term of the binomial here, and we put in the final answer. And the same sign of positive is written in between them. It means to say we can examine our trinomial factor here. Here is x squared. This is the square of the first term of the binomial. The middle term is negative xy. This is the product of these two terms, x and y. But we should write the opposite sign. If we multiply x and y, it will give positive xy. But in here, the sign must be the opposite. Should be negative. So negative xy in the middle term. And the third term of the trinomial is y squared. And that is the square of this y here. So it is y squared. Binomial is x plus y, and the trinomial is x squared minus xy plus y squared. Your special product is simply the x cubed plus y cubed. Now let's have a quick multiplication to confirm the product of this binomial and trinomial using our long method. So I'm going to multiply the x with all the terms of the other group. Then later I will multiply the y with all the terms of this trinomial also. So it will appear like this. X times x squared, we will get the x cubed. Then x multiplied by negative xy, we will get this negative x squared y. Then x times the y squared, we will get this xy squared. Next is for the y term here of the binomial. I'm going to multiply first with the x squared. The answer is x squared y. Next is the y multiplied by negative xy. We will get this negative xy squared. And the y multiplied by y squared, we will get this positive y cubed. And from here, we're going to look for like terms. So this negative x squared y, there is a positive x squared y here. Also, this xy squared, positive, there is another term which is same literal coefficient xy squared, and this is negative. So it means to say we can cancel these terms respectively, and then we will collect the terms that will remain. Obviously, this is x cubed that will come, and also the plus y cubed. So this is our final answer. As you can see, this answer is the same with our special product that is written up here. Now we are ready to use this formula when we encounter multiplication of polynomials of this pattern. Let's have example 1. b plus 3 multiplied by b squared minus 3b plus 9. First, let us analyze each term if pattern is met. So there is no question with the binomial. We will simply check the trinomial part. Okay, so the first term here of the trinomial is b squared. It is simply the square of this b. So the first criterion is checked. The middle term, if I multiply b by 3, I will get positive 3b, but I should write the opposite sign, negative 3b. So the second criterion is checked also. What about the third? The third term is 9. So this 9 is simply the square of the number 3. So the third criterion is checked. So it means to say the pattern is met. In that case, what we'll do is we're going to write here two blanks to represent our special product. In the first blank, I will copy the b, I will put in the first blank, and then put the power 3. And then I'll make sure that this is plus. And for the second blank, the 3 will be put on the blank, and then we'll put the power 3 or cube. And then we will simplify. So the b raised to 3 will be b cubed, and then the 3 cubed will be 27. So this is our final answer. Let's have example 2. 2x plus 5y is the binomial, multiplied by the trinomial 4x squared minus 10xy plus 25y squared. We can rewrite the problem into same pattern of the special product. So for the 4x squared, we can rewrite this as 2x raised to 2. For the negative 10xy, we can factor this out in such a way that we can see the terms of the binomial. So the 2x and the 5y are there, and the sign must bear the opposite. So 2x and the 5y, and then the minus sign is here. And for the third term, the 25y squared, we can write as 5y all raised to 2. So we can say that the pattern is met. So what we'll do now, we'll go to that same problem, and then we'll put the equal sign. We will now put the two blanks to represent the two terms of the special product. Let's begin with the first blank. I will collect the 2x, and I will put the power 3. And then plus. For the second blank, the 5y is copied here, and then power 3. We will simplify further. The 2x raised to 3 is equal to 8x cubed, and the 5y raised to 3 is 125y cubed. So this is our final answer. Let's go now to the second type of special product. We have this binomial x minus y multiplied by the trinomial x squared plus xy plus y squared. In the books, you will find that the special product for this is a binomial which is equal to x cubed minus y cubed. If we look at our binomial here, it seems like we simply take the cube of this x and write here, and for the sign, if this is minus, same negative sign is coming here. And then the y is copied, and then with power 3. So we're going to analyze the trinomial. So this is x squared. This is simply the square of this x. The middle term is xy. So it seems you're multiplying the x and negative y. But we should write the opposite sign, because if I multiply x by negative y, I will get negative xy. But based on the pattern, I should write the opposite sign. So this is plus xy. And the third term of the trinomial is simply the square of this negative y. So negative y is squared, it will give positive y squared. So if a certain multiplication of binomial and trinomial falls on this category, we can simply write the final answer as a simple one. this is x cubed minus y cubed. Formula B or special products A and B have similar pattern. Now we are ready to see example 1. So this is AB squared minus 2 is our binomial. In the trinomial, it's written a squared b raised to 4 plus 2ab squared plus 4. And then we can rewrite the problem into same pattern of the special product. For the binomial, we simply copy. Now, for the first term of the trinomial, let us show that this is the square of the first term, ab squared. So this is ab squared, and then the power 2 is outside. If we simplify this, we will go back to our a squared b raised to 4. Then next, the middle term. Let us show that this middle term is the product of this binomial. So ab squared is here, and the negative 2 is here. But when we get the product of this, we should write the opposite sign. Okay, if we multiply these two, we will get a negative sign, but in the pattern, we should write the opposite sign, so this is plus. For the third term, we should show that this is the square of this second term of the binomial. So this is negative 2. If we square this, it will go back to our positive 4. So it means the pattern is met. In that case, we will go back to our problem. Then we will put now the special product. Let us write the two blanks to represent our two terms of our product. So the first blank here, we're going to copy the ab squared. We'll write here and then put the power 3. And then we should write the negative. And for the second blank, the 2 is copied and then write the power 3. Then we will simplify now. So this term here becomes a cubed b raised to 6, and then minus the 2 cubed is 8. So our final answer is a cubed b raised to 6 minus 8. Let's have example 2. This is 5xy minus 1 multiplied by the quantity 25x squared y squared plus 5xy plus 1. So again, we will check the pattern. We will rewrite this problem and see if this pattern falls on our special factors pattern like this. So there is no issue with our binomial. We simply copy that. Now for the trinomial, we will check one by one. The first term, it must satisfy that this is the square of the first term, the 5xy. So this 5xy, if we square this, we will get back to that 25x squared y squared. So the first criterion is met. And then for the middle term, let us show that this is the product of the two terms of this binomial. So the negative 1 is here, the 5xy is here. If we multiply this, we will get a negative sign, but as a rule, we should write it as positive. So the second criterion is checked. Let's see the third. The third criterion, we should show that this 1 here is the square of the negative 1. So if this negative 1 is squared, it will go to positive. So again, the third criterion is checked. It means to say the pattern is met. In that case, we will go back to our problem. Then we will write the two blanks to represent the terms of the special product. For the first blank, I will collect the 5xy, then I will put power 3. Then followed by the negative sign, and then for the second blank, the 1 will be raised to 3. Then we'll just simplify. The 5xy raised to 3 becomes 125 x cubed, y cubed, and then minus 1 cubed is 1. So this is our final answer. Let's go now to our third type, and this is square of trinomial. As you can see here, we have three terms, x plus y plus z, all raised to 2. In the book, you will find that the answer for this is 6 terms. So let us examine one by one. We can group the 6 terms into 2 groups. The first 3 is one group. The last 3 is another group. So let us examine the first 3 terms. So these 3 terms are actually the square of each of the terms of the binomial. So you see, the x is squared here, the y is squared here, and the z is squared here. For these last 3 terms, the pattern is we're going to multiply 2 terms at a time and then multiplied by 2. So you see here, the xy is multiplied together and then times 2. The x and z are multiplied together and then times 2. The y and the z are multiplied together and then times 2. And that's it. This is now our special product for the square of trinomial. Let's have a quick multiplication to confirm if this special product is actually the same answer if we're going to have a long method of multiplication for this square of trinomial. So what we'll do, we're going to expand, so we can show that this is x plus y plus z times x plus y plus z. Then we will do a long multiplication. So this variable x, I'm going to multiply to all the terms of the other group. So it will come like this. X times x will get x squared, x times y is xy, x times z is xz. Next, the y, I'm going to multiply with the x, I'll get xy. Then y times y is y squared, y times z is yz. And then plus. Now the z multiplied to the x, it is xz. Z multiplied to the y, it is yz. And then z multiplied to z will give z squared. And then I'm going to remove the grouping symbol and then to combine like terms, if any. But in writing my final answer, at first, I'm going to collect all terms with squares. So this is x squared, there is y squared, there is z squared. I'll write them first in here, and then I will collect the like terms. There is an xy here, positive, there is positive xy here. So combining them, I will get the 2xy. The xz in blue color, there is another xz here in blue color. They are like terms, so we can combine them to be 2xz. Now, the other one is the yz, positive. Another positive yz is here. We can combine them together. We will get the 2yz. So, this is our final answer with 6 terms. So, these 6 terms, the final answer here is same with our special product written on top. So, it means to say, we can now use this special product to solve problems that will fall on this pattern. So let's have example 1. A plus 2b minus 5 all raised to 2. So as per our special product, we're going to square each term of this trinomial. So you see here, the a is squared. The 2b is also squared here. The negative 5 is also squared. So this comprises our first group. And for our second group, we're going to multiply 2 terms at a time and then multiplied by 2. So at first I'm going to multiply a and the 2b and then times 2. So you see here 2 times a times 2b. Next I'm going to multiply a and the negative 5 and then times 2. For the last term, I'm going to multiply 2b and the negative 5, it's here, and then times 2. Next, I'm going to simplify now the 6 terms. So this term here becomes a square. The 2b square is 4b square. The negative 5 is squared, it becomes positive 25. For the fourth term, this 2 times a times 2b will give 4ab. For the fifth term, we multiply 2 times a times negative 5, we'll get negative 10a. For the last term, we multiply 2 times 2b times negative 5. So this is negative 20b. So for our final answer, this is a square plus 4b square plus 25 plus 4ab minus 10a minus 20b. Let's see example 2. 3x minus y square plus 10 all raised to 2. So let us use our special product. Let us square each term here. So 3x is squared. The negative y square is also squared. And the positive 10 is squared. And for the second group, I will collect 2 terms at a time and then multiply it by 2. So first I'm going to multiply 3x and negative y square. It's here and then times 2. And then plus, I'll multiply 3x and the 10. It's here now, 3x times 10 and then times 2. And the last term, I'll multiply the negative y square and the 10. It's written here and then times 2. Then we will simplify each term. The 3x raised to 2 becomes 9x squared. This negative y square and then square outside, the negative will go away. It becomes y raised to 4. The 10 square is now 100. So the first group is now complete. I'll go to the second group. For the fourth term here, I'm going to multiply 2 times 3x times negative y square. So the negative sign comes here, and then 6, and then x, then y square. For the fifth term, I'll multiply 2 times 3x times 10. It will give 60x. And the last term, I will multiply 2 times negative y square times 10. So the answer is negative 20y squared. So we have now the 6 terms as our final answer. So this is 9x squared plus y raised to 4 plus 100 minus 6xy squared plus 60x minus 20y squared. One more point that I want to make. Since we are putting square to each term of this trinomial, it means to say the first 3 terms in the final answer must always be positive. Thank you for watching the video. See you again next time.